We can start, sir.
Okay. So for better network, I'm turning off my camera. So let's start the session. So in this session, basically we are going to learn about different components that we use basically in EV powertrain, and then we will learn about like how to select different components which are suitable for particular applications, and then we will go for the modeling part, how we can model our entire EV four-wheeler, and later on we'll also see how we can analyze different performance parameters using different tools of Matlab. Okay. So before, so first of all, like there are several powertrain components that we are going to use. Basically, let me tell you what is basically powertrain means. So powertrain is a system which basically converts the electrical energy in terms of mechanical energy, and then it transfer it to the wheels so that the vehicle can move. So whatever components, whatever different things comes under that whole system, those are basically powertrain components. So I will request all the participants, please mute yourself. Okay. So in the powertrain component, the most important component which basically converts the electrical energy into mechanical energy is called electric motor. Now, definitely, electric motor has some advantages over general IC because of its high starting torque and exceptional efficiency in converting electrical energy to mechanical energy. So there can be different types of motors that we can use in electric vehicles. It depends on the applications for which we are developing that electric vehicle. Maybe it's a two-wheeler, maybe it's a three-wheeler, maybe it's a four-wheeler, or maybe it's a heavy vehicle. So ultimately, there can be DC motor, WLTP motor, PMSM motor. It can be any type of DC motor. Even it can be AC motor like induction motor and others. Now, the another important component which comes under this powertrain is battery pack. Now, what battery pack? Battery pack is nothing but a collective of multiple cells in a collective manner so that we can get the expected voltage and capacity, which can be further converted in terms of power to run our motor and finally to run the vehicle. Now, there are several parameters that we should remember while selecting a cell to make a battery pack for our application. Now, if we categorize those, there can be almost 10, 11 parameters that we should remember. Like there can be flexibility, one of the parameters. It can be cycle life of the cell, how many cycles we can use for the battery. So cycle means basically how many charging and discharging cycles we are getting out of the battery. Okay. Then the temperature range, like based on as lithium ion battery is more popular for this electric vehicle industry. So for each of the different type of lithium ion chemistry, it has a different temperature range. In which range, if you operate the battery, you will get the maximum efficiency out of it. So you should keep remember the temperature range, like in the particular applications where we are going to use that battery. So in what temperature range the temperature of the pack will vary. You should keep remember that. Then another point is commercial availability. That battery you are selecting for your pack, it should be available very easily. Then volume or the overall size, how much big is each of the batteries or cells are, because wherever we are going to use, there should be a space constraint, right? So you should select the cells based on that. Again, there will be operational life, like when we are actually operating the cells, how much operational life we can expect from the cell. It can be shelf life when we are not using the pack, when we are not using the cells. So at that point, how much the self discharge rate is, or how much time we can keep in idle mode without using it, and we can expect the same performance out of the battery. Right? There can be another parameters like in term of cost for any engineering development process, for any engineering project. Cost is one of the important parameters because ultimately you are going to sell it in the market, and you should keep remember that cost effectiveness of the application. Right? Then there can be voltage, another parameter. You should select the cells according to the requirement voltage. and also you have to connect those cells in different series and parallel configuration to meet your requirements. Then power density and energy density. So in very layman term, energy density results for higher range, where power density results for higher power to the motor, and in term like higher speed, higher acceleration for the vehicle. Okay, so you should select the cell which will have obviously great energy density and also a high power density as well. And finally, for any commercial product, you should be concerned about the safety aspect of the component. So for the battery also, you should consider the safety aspect of it. And finally, whenever you are selecting a right battery, so it involves a comprehensive evaluation of different parameters that I told, like almost 10, 11 parameters. So each contributing to overall performance, safety, and economic viability of the chosen battery technology. So balancing all these parameters is very complex endeavor for developing a battery pack. So those points basically is mentioned here, like in terms of lifespan, reliability, weight and size, energy storage capability, like energy density and all. You should select those things carefully. Now, another component that comes under the powertrain system, which is called power distribution unit. You can consider this power distribution unit as a junction box, where uh, terminals from different parts, maybe from battery and the connection between the motor and battery, that comes under power distribution. Also, the auxiliary systems which need power, that also comes under power distribution unit, the terminals of it, and also the charging through which you are going to finally charge your battery pack, that terminals also comes under power distribution. So it's basically a junction box. So from this junction box, based on different algorithms, different techniques, whatever power requirements are there based on different loads, it will be transmitted to those parts. Okay, it's basically a junction box. So the components, the bus bars, the proper torque that you are like tightening that bus bar, that torque, the component of the sensor or the fuses for safety. So those components you should have to select carefully based on the power requirements, like how much amperes or how much heat basically at that power distribution unit or particular at that point is going to generate. Based on those things, you should select those components. Okay. And finally, as when you are driving a vehicle, it will run over different bumps, different potholes, and uh, different kind of roads, right? So your power distribution unit should be flexible enough so that uh, it can adjust or it can be safe in those kind of vibrations and those mechanical shocks. Okay. Then another important component for this powertrain system is inverter, or you can say as converter as well, based on different aspects. Sometimes we use inverter, sometimes we use converter. So ultimately, inverter is a component which converts DC to AC, DC type of current to AC type of current. Okay, and converter is a type of system which basically it basically converts the power. It can be input can be DC to AC, input can be DC to DC, input can be AC to AC, or whatever the thing is. But ultimate purpose of the converter is to convert the power. Means whatever input you are giving, it should provide the output based on the required voltage and current. Okay, but it will keep the power same. Okay. So in this converter and inverter, like as it's converting the type of energy, so the efficiency of this should be considerable one. It should be high enough. And also like when your vehicle is like uh, running, but you are not supplying any power, maybe you are going downhill direction. So at that time, due to gravity only, it will rotate the wheels, right? At that moment, your motor can be acts as a generator, right? Which can generate energy from that kinetic energy and recharge your battery pack. So for those purposes also, you should have a generator and a converter. Okay, basically. Then, as I told, like charging is another important function for any electric vehicle. So it should have an onboard charger. So there are some parameters or some aspects that you should remember while you are selecting the charger. So obviously the first one will be efficiency. So it should be efficient enough. Then the versatility. So whatever charger type you are using, so there are different types of standards for the charger ports and connectors, right? Now you should have a provision to accommodate all of the different type of chargers. Some of the chargers will charge your vehicle slowly. Some of the charger will charge your vehicle very fast. So you should have provision for all of the different type of chargers. And finally, the user interface through which the user can understand the, yeah, actually charging is happening, or yeah, actually the connector is connected perfectly to our port. So those things also, the user interface part also comes under this thing. So here I have given one case study for Tesla Model S, which is one of the very uh, like very sophisticated electric vehicle in terms of different parameters, in terms of range of the vehicle, in terms of the luxury of the vehicle, in terms of the performance, or in terms of the very using of very sophisticated IoT devices. Right? So let's understand the Tesla Model S. What are the different features are there, and what are the different components they are using in Tesla Model S to make this a different, like a, a very sophisticated one, okay, comparatively to the other models of different manufacturers. So in terms of motor, so the motor efficiency basically is not constant throughout your driving. It can change based on different RPM rate, different torque rate, different power input can change. But you should remember, whatever motor you are selecting, whatever conditions you are it's running for, it should have a overall efficiency which will be more than 90%. So in Tesla Model S, the efficiency in overall driving, it ranges between 90 to 95%. And in term of range, so basically the Tesla Model S has a estimated range of 800 kilometers, which can change based on different weather conditions, different drivers, different driving patterns, and also different road conditions. So we'll discuss those, like how environment can affect this range and all. Now, if you see different parameters of Tesla Model S, so first is battery. Now there they are selecting a battery pack which has a energy of 100 kilowatt hour. The type of lithium ion battery, and total number of cells they are using in that to make that pack is 7,920. So basically 18650 size cylindrical cells. What does this 18650 mean? 18 is the diameter and 65 is the length of the cell. Okay, height of the cell, you can say. The cylindrical type. And also the reliability part, the warranty period they are giving of 8 years. So if you drive your vehicle throughout 8 years, there should be no issue. So it has a cover of warranty for 8 years. Warranty mileage, in terms of mileage also, they have provided 2,40,000 kilometers. Now, though you have 100 kilowatt hour of energy in the battery pack, but actually the usable capacity is only 95 kilowatt hour, because the cell life or the cycle life of any battery or cells, it depends on the total throughput. What does this throughput mean? Throughput means basically how much charging capacity you are putting inside your battery, or during discharge time, how much capacity you are taking out of the battery. This sum of those two values. Okay. So if throughput is high, then obviously the impact in term of the cell's performance will degrade. If your throughput is low, the efficiency or the performance of the cell will be high enough. Okay. So to limit that throughput, they are allowing only 95 kilowatt hour out of this 100 kilowatt hour. So you can say, based on these parameters, based on this two parameters, this 95 kilowatt hour and 100 kilowatt hour, you can say the DOD or depth of discharge for this Tesla Model S pack is 95%, because out of 100 you are using only 95 kilowatt hour. Okay. DOD is 95%. Basically the battery lithium ion chemistry they're choosing for it, it's called NCA, nickel cobalt aluminum oxide type of battery. So basically in every battery, in whatever the type of battery is, it will have three components basically: cathode, separator, and anode. Okay. And in between, like in both two sides of the separator, there will be electrolytes which will basically transfer the ion from cathode to anode. Okay. In most of the lithium ion batteries, the cathode chemistry is basically the chemistry name that you can see for that lithium ion battery. So as here, this type of battery is NCA, that means the cathode material they are using is NCA type, and the anode material will be of graphite, okay, a carbon compound. So as they're using total 7,920 cells to make this 100 kilowatt hour of battery pack. So their pack configuration is 110S72. That means in series they are connecting 110 cells, and in parallel they are connecting 72 cells. So overall number will be 110 multiplied with 72. That will be the total number of cells. Okay. So as you can see, the total energy is 100 kilowatt hour. So total voltage they are getting for this pack is of 407. So when you connect multiple cells in series, so basically each cell's voltage got add up. So 110 cells you are using in series, right? So each of these cells voltage will be 407 divided by 110. So that will be each of these cells nominal voltage. Okay. And capacity in term of parallel configuration, you can relate it with. So as many numbers of cells you are connecting in parallel, so the capacity of the cells will add up, but the voltage will remain same. So from this 100 kilowatt hour, if you divide this 100 kilowatt hour value with 407, you will get the actual capacity. This is not the capacity actually, this is the energy. If you divide this value with 407, you will get the actual capacity. And you can divide that actual capacity with 72 by 72. You'll get individual each cell capacity is how much. Then in terms of performance that we are expecting from the Tesla Model S, so the acceleration from 0 to 100 km per hour, it can go in 3.2 seconds. The top speed that we can expect from Tesla Model S is 250 km per hour. The actual range, though they are claiming you can expect up to 800 km of range, but actual range that you are getting from this Tesla Model S is just 575 kilometer. But again, it's supposed to change based on different environmental conditions and driving patterns. Total power for the motor is of 504 kilowatt, and total torque is like you can calculate based on the force you are using here and the diameter or these basically the radius of the wheel you can calculate from there. Okay. And Tesla model is all-wheel drive, means as Tesla model is a four-wheeler, so individually four wheels have connected with the transmission. Okay. So all the four wheels will have power. Now, in a real time, as the range and consumption can vary, and obviously like based on the consumption range, the range will also change. So in real time, based on EV database of this Tesla Model S, they're saying that the real time range is 575 kilometer, and the consumption rate is 165 watt hour per kilometer. What does this mean? This means to run your Tesla Model S for 1 kilometer, your battery pack will be consumed, your motor will consume 165 watt hour of energy. And as it is a complete battery electric vehicle, so you are not using any IC engine or any fuel. So the CO2 emission is 0 gram per kilometer. Now here we have a real world performance scenario based on different weather conditions and different range. So basically in city drive for cold weather, someone is unmuted. Please mute yourself. Okay. So in city driving condition, based on cold weather, you can expect around 540 kilometer of range. In highway, same as cold weather, you can expect a 420 kilometer of range, because at highway we will drive in higher speed, right? And higher speed will consume more energy, and that's why this range got reduced. Again, if you are driving in combination of city and highway mode, so at that condition, you can expect around 480 kilometer of range. And in mild weather condition, in city, you can expect around 820 kilometer of range. In highway with same mild weather condition, you can expect a 550 kilometer of range. And combining range for both city and highway in the same mild weather condition, you can expect around 665 kilometer of range. So from here, you can understand that based on the road condition, based on the weather condition, the range changes. Now, as we, in the initially, we were telling you that you should select the charging onboard charger type based on different type of chargers. So in Tesla Model S, it has uh, like both, it supports both type of charger. It supports regular slow charging and also fast charge. Okay. Now, how much slow charge means and how much, what is the fast charge means, that you can see here. So you can charge with one plug of 2.3 kilowatt of input power, where if you charge for 1 hour, you can expect around 12 kilometer of range. Also, it supports 3.7 kilowatt of slow charging, where you can charge it for 1 hour and you can expect around 19 kilometer of range. It also supports three-phase 16 amp socket, which is like based on Europe condition, which is 11 kilowatt. Here, like if you charge for 1 hour, you can expect around 56 kilometer of range. Also, the first charging provision is also there. So in case of CCS, combined charging system, you can expect around, like to make it full charge, it needs around 84 minutes of time. Okay, where if you charge for 1 hour, it will give you 280 kilometer of range. Also, it supports supercharger version 2, which is made by Tesla, which provides 150 kilowatt of input DC supply, which can charge your vehicle 630 kilometers in 1 hour. So you need to charge 38 minutes to full charge your whole vehicle. Also, it supports 250 kilowatt of DC input, which is called supercharger version 3, which can give you 800 kilometers of range in 1 hour. Okay. Now, whatever the certification or whatever claiming range are there, basically claiming range it depends on different testing modes, right? Now, again, it depends on which driving cycle they're following to test the vehicle range. Now, based on WLTP driving pattern, which is type of TEL, it can give you around 649 kilometer of range. And at that condition, your vehicle consumption rate will be 146 watt hour per kilometer. And if you are testing your vehicle at WLTP TEH type of driving cycle, your consumption will be 150 watt hour per kilometer, which is comparatively higher than the initial one, this one. Here you can expect a little lowering around 634 kilometers. And finally, by looking all the parameters, you can understand that it's using a very sophisticated advanced technology to give a very high and very powerful powertrain to your vehicle in terms of performance, in terms of reliability. And as it's a complete BEV, so CO2 is not getting emitted to the tailpipe and also other hazardous gas. So it's a sustainable based on the environmental degradation conditions, right? And also the different functions are there in terms of ADAS, advanced driving assistance systems, where it can have autonomous driving mode, it can have a cruise control, it will have a traction control. So those combination of those X-by-wire concepts and those advanced sophisticated driving assistance systems it has a driving innovation that also can be reflected here. Okay. Now, this is the case study that I want to show you about Tesla Model S. Now, I will quickly jump over the selection of powertrain components. How you can select different powertrain components, okay, for particular vehicle. Now, before all of this, you should be familiar with whatever is drive cycles. Okay. There are different type of drive cycles. What does this drive cycle mean? Drive cycles means it's a relation between speed and time, which gives the driving pattern. Okay. Now, here I am showing you one driving cycle, which is called FUDS, or Federal Urban Driving Schedule. Here you can see the x-axis is representing the time in term of second, minute of second, and in y-axis it's showing speed in term of kilometer per hour. So as you can see, the speed is changing over the time. Okay, you can see this driving pattern. So till 20 seconds, the speed is 0 only. Then it started to accelerate. It's again reached in this point where the speed is almost 36 kilometers per hour. Then again it's deaccelerated, applied some brake. So in this mode, as vehicle is deaccelerating, you can use regeneration to recharge your vehicle throughout with the help of your generator. Okay. Again, it's accelerated, again it's deaccelerated, and like this way, again it's accelerated, it comes to 0, again it's accelerated. It's following this nature of driving time. Now, the same graph, if I show you in terms of data points, you can see this is the A column is representing the time in second unit. B column is representing the mile per hour speed, which is going almost 1372 seconds, I hope. Let me check one. Yeah, 1372 seconds. So at each second, what is the speed you are getting out of the vehicle? Okay. So you should consider your vehicle parameters in terms of the vehicle mass, in terms of the vehicle shape, how much air drag coefficient or CD value you are expecting, how much frontal area is there for your vehicle, based on the tires, based on the road surface, how much rolling resistance coefficient you are getting, that value, and also the wheel radius. You should have these many parameters. If you have these many parameters, you can you can select your powertrain and also the consumption for a certain range you are expecting out of the vehicle, and you can calculate all those things.
Hello, sir.
Yes,
The graph is not visible, sir.
Just a minute. Uh, I hope you can see my screen now.
Yes, sir. Yes, sir.
Okay. So this was the graph that I was showing to you. Okay. This is the x column, which represents the time in second unit, and this is the y-axis, which is representing the speed in kilometer per hour. Sometimes you can see the speed is increasing, sometimes it's decreasing, again it's increasing. So whenever it's decreasing, it's deaccelerating. Right? That means in this point, you can regenerate energy from the kinetic energy. That your wheel is rotating, right? But you have applied brake. So at that point, you are not supplying any energy to your motor. Right? Those points, you can regenerate energy and recharge your battery pack. So the same points that you can see in terms of graph, same points is here in terms of data points. Here A column is time. Suppose at 0th second, your speed is 0 mile per hour. At 1 second, your speed is 0 mile per hour. Similarly, like if I go here, at 22 second, your speed is, let's say, 5.9 mile per hour. In terms of kilometer per hour, it is 9.4931 kilometer per hour. And in meter per second, it is 2.6369 meter per second. Okay. It's an instantaneous speed. Don't get confused that like for 22 seconds your speed is this. Don't get confused. At 22 seconds your speed is this much. At 23 seconds your speed is this much. Okay, it's an instantaneous speed. Now I hope most of you know about different tractive forces, different road loads. When any object moves over a road surface, what are the resistance force, what are the forces that acts on a object to resist the speed, resist the motion. Now, in case if you want to move your vehicle, if you want to further run your vehicle, you need to overcome those resistive forces, right? So, first we should calculate those resistive forces. Basically, whenever a object rolls over a road surface, basically there are four different type of road loads that acts on it. What are those? So due to the tire friction over the road, there will act rolling resistance force. Due to the aerodynamic resistance over the vehicle surface, vehicle body, there will act aerodynamic drag force. It will also, like if you want to accelerate your vehicle, like as you've seen in case of Tesla, it can accelerate from 0 to 100 in 3.2 seconds. So those type of acceleration, you need another type of force, which is called acceleration force. You have hill climbing force. Suppose you are going in uphill direction or downhill direction, you should have an extra force that is given to your motor to keep the same speed, but going in uphill direction. So there will be another force which is called the hill climbing force. And summation of all the individual four forces is called tractive force. Okay. Now, first rolling resistance force. The formula to calculate rolling resistance force is mu rr into mass of the vehicle into g. Mu rr is nothing but the rolling resistance coefficient that you should have before calculating these things based on the tire specification. Okay. Now, using the same formula, I know mass is this much. The gravitational constant is the value of g is 9.81 meter per second square. You know this value. So you can multiply these three parameters and you can calculate the rolling resistance force. Okay. I have used the Excel formula and applied the same formula in throughout this column. Okay. As vehicle speed is not dependent on this rolling resistance force, that's why throughout the driving, the rolling resistance force value is same. Right? And then next one is aerodynamic drag force, where I am using half into rho into CD into A into V square, where half is just a constant. CD is the drag coefficient, which depends on the vehicle structure or the vehicle shape, how the shapes look like. If it is a van type, it's a hatchback type, it's a like what the type of structure is, shape is, coupe type, or whatever the shape of the vehicle is. Then it should be multiplied with the frontal area of the vehicle. That value already I have. Then you should know the air density. So again, air density is supposed to change based on different environment, different weather conditions. If you go to Himalayas, there will be a different air density. If you are in Mumbai, there will be a different air density. If you are in Delhi, there will be different air density. It's supposed to change, but we can consider a constant value, which is 1.225 kg per meter cube as the air density. Then it will be multiplied with rho, which is nothing, rho I told you, which will be multiplied with v square basically, which is the speed in meter per second. So all the formula that we are going to use here, all the formula will be applied on the meter per second speed, not in mile per hour, not even in kilometer per hour. Whatever the speed is given, you should convert it into meter per second, and then you can calculate these things. Okay. Then you have another type of force, which is acceleration force. Now, acceleration force formula is mass of the vehicle into the acceleration. Now, you have only speed. You have to calculate acceleration. Now, acceleration is what? So, what is the difference? Like acceleration is what? Final speed minus initial speed divided by time, right? Now, suppose I am considering at this condition. So at this point, your final speed is this much, right? 1.3408, this, right? This is your final speed. What was your initial speed? Your initial speed was 0, right? So final speed minus initial speed divided by time. Now, if you see the time, as I told, time is instantaneous, right? So each second time is given. So difference between this point and this point is 1 second. So this value minus this value divided by this difference of time interval, 1 second. That will be your acceleration. So that I have calculated, which is nothing but 1.34. As the time interval is 1 second, that's why I didn't divide it with 1, because the value will be same. Right? So that's how I have calculated the acceleration force, acceleration value. Then in this next column, I have multiplied the mass of the vehicle with the acceleration, and I have calculated the acceleration force. As acceleration is changing based on different time, so the acceleration force value is also different. So in some points, when it's deaccelerating, you can see the value of acceleration force is negative, because here you can regenerate energy. You can get 100, you can get this much of energy, but again, how much energy your vehicle is recharging with, that depends on the efficiency of your generator and also the other components that you are using. Now another force is hill climbing force, which formula is mass into the gravitational constant into sine of the angle. Angle will be in radian unit. So here I have considered the angle is 0. I am considering that vehicle is going in flat surface only. So I have kept this angle as 0. So sine 0 is 0 only. So overall this value will be 0. So throughout this drive cycle it is 0. Now you should add all these individual forces to calculate your tractive force. So here I have added all these individual forces and I have calculated the tractive forces. Then tractive power, to convert tractive force to tractive power, you need to multiply velocity. Velocity will be same in meter per second, okay? The respective velocity of the time. Okay. So tractive force multiplied with the velocity I have calculated. Because till 20th second, the speed is 0 only, so it's 0 only. When actually the vehicle starts to run, there you have some speed, so you have calculated some power here. Okay. Then total power transfer. So individually at each point you are discharging this much of power from your battery, right? But how much total power you have discharged throughout your drive cycle? That total power transfer, or the value of joule, you can sum the overall tractive power and you can calculate. So to calculate this sum of all these things, but you should neglect the negative value, because those are available to regenerate. That is your benefit. If you have regenerative efficiency high enough, you can regenerate a good amount of energy out of that. But don't consider that value while selecting your powertrain component, because that is your benefit. So you should consider whatever energy, whatever power you are delivering. So that to calculate that, I have used a formula or a condition basically. So whatever in this column, whatever values are greater than 0, just consider those things only and sum those values. Okay, so I have used sum if throughout this column, whatever value is greater than 0, just sum it. So I'm getting this much joule. Okay. This much joule of total power is transferred to the motor from battery in this driving cycle. Now this much power I understand, but this much power means how much energy basically my vehicle is discharged with. So to calculate the energy, you should divide this value, if it is in watt second or if it is in joule, you should divide this value with 3600 to calculate the watt hour of energy. Okay, so same thing I have calculated here. I have divided this value with 3600 and I am getting 313.86 watt hour of energy that I'm consuming in this driving cycle. And this much energy I'm consuming, but actually how much distance I'm going. So that distance also I have calculated by summing up the meter per second speed, because meter per second, right? So at 1 second, your vehicle is moving this much meter. So if you want to calculate distance, you just need to multiply time with this meter per second. So the time will be 1 second because this is instantaneous speed, right? So if you just sum all these meter per second speed, you will get the total distance in meter. Now to convert in term of kilometer, I have divided it with 1000. Okay. So in this drive cycle, my vehicle moves around 11.987 kilometer of distance, and it has consumed 313.86 watt hour. That means my average consumption rate or standard consumption rate for this drive cycle is 26.1824 watt hour per kilometer. Now, if you know what is your consumption rate is, now suppose I am expecting that my vehicle should have a 200 kilometer of range. So for one kilometer, my vehicle is consuming this much watt hour. For 200 kilometer, how much watt hour it will consume? Just simply multiply this value with the expected range. So which is in this case is 200. So I have multiplied it and I am getting around 5236.49 watt hour of energy. Now 5236.49 watt hour means how much? 5.23 kilowatt hour. Just divide with 1000. Okay. Okay. In case of two-wheeler and three-wheeler, there is a reference I can say you. If you want to select the battery voltage, if your top speed of the vehicle is in between 0 to 55 kilometer per hour, you can go for a 48-volt battery pack. Not battery pack, the overall powertrain architecture should be a 48-volt. If your top speed is around 55 kilometer per hour, you should select a motor or powertrain components which will run on 60 volt. Okay, and in case if your top speed is around 90 to 140, you should select a 72 volt components. Okay. Now for our case, if I calculate, if I check the top speed, which I have done here, so I'm getting my top speed is around 91.2303 from this drive cycle, from this kilometer per hour, the maximum value in this column, okay, which is 91.23 kilometer per hour. So based on this value, I can see, so I should go for a 72 volt architecture. So I have selected 72 volt architecture. Now, based on that, so I should have this much energy, this much watt hour of energy. So, and I'm going for 72 volt battery or 72 volt powertrain component. That means how much capacity my battery pack should have. So this value, this energy value divided by voltage. So watt hour divided by volt equals to ampere hour that you are calculating. Okay. Now same thing to select your motor. Now here you have already selected your battery pack, right? 72 volt voltage and 72.72 ampere hour of capacity your battery pack should have. In case of power, motor power, what maximum power your motor should deliver? So in the tractive power column, you should check how much maximum power I am using instantaneously. Now, suppose you consider this much value only, okay? Only this much value. You can see the maximum value in these 4 points is 1335 point this much. So if your motor can deliver 1335 watt of power, obviously it will deliver 922 watt of power also. It can also deliver 350 watt power also, because those are lower value. So similarly, in this whole column, you should check what is the maximum power I am using instantaneously. So same thing I have checked and I got around 6,839 watt, which is around 6.83 kilowatt of power. So whatever motor I am selecting, our motor power, the motor's peak power should be around 7 kilowatt or 6.83 kilowatt. Okay. Generally, so for every motor, you will see two power parameters. One is continuous power parameter, another one is peak power parameter. Okay. So this is your peak power parameter that you have selected from it. Generally, it depends on manufacturer, but generally, the peak power of a motor is √3 times of your continuous power. So if you are considering this as your peak power, so your continuous power will be around 4 kilowatt or 3.94 kilowatt. So you should select a motor which will have a 72, which will run on 72 volt and can deliver a continuous power of around 4 kilowatt or a peak power of around 7 kilowatt. Okay. Again, you have selected your motor and your battery pack. Now time to check for the torque you need and also the RPM you need to provide. Okay. Now to calculate RPM, you should calculate the wheel circumference. Now wheel is a circular body, right? You know the wheel radius, which is 0.3 meter. Now if you want to calculate wheel circumference, so formula is 2 into pi into r. So you are calculating the wheel circumference is around 1.884 meter. Now you have speed, right? Meter per second speed. Now what does this RPM means? RPM means revolution per minute, or in layman term, how many rotation it's doing in each minute of time. So if you simply convert your meter per second speed by multiplying 60 to meter per minute speed, so you already know that this much meter per minute speed I need to maintain. You know this is my wheel circumference. So to achieve this much of speed, how many times you need to rotate your vehicle? So simply divide this value with your wheel circumference of 1.884 meter. You will get the RPM. Okay, that's what I have calculated here. So this is the RPM required at each point of your driving cycle, instantaneous values. Okay. Now around this, now you also same like motor power, same like other things. You should check for the maximum RPM that your motor needs to deliver. So I have used max formula, max of the column, and I am getting around 807.062. So around 809, 808 RPM. So your motor should deliver 809. Actually, this RPM is based on your wheel. Okay. And if your motor is delivering a different RPM, so you should convert that with a proper gear ratio in this point, in this term. Okay. This is your wheel RPM required, 807. Similarly, to calculate the Newton meter or the torque required in your wheel, you can simply multiply your tractive force value with your wheel radius, that I have done here. So I have multiplied the tractive force with the wheel radius, that is 0.3. I have calculated overall the driving cycle, what is the torque required. Now same, I am calculating the maximum torque I need to provide, which is 98.55 Newton meter, okay, which is around 99 Newton meter. Now, whatever motor you are selecting, so that will be of 72 volt and this much of peak power, right? Now, if you are searching in some website, you will see, suppose motor is delivering, let's say, 1000 RPM, and it is also giving you a Newton meter or torque of, let's say, 30 Newton meter of. Okay. Now this is your motor parameter, and you need in your wheel actually 807. Okay, let's consider not 1000. Let's consider 3000. Okay. Generally, the RPM ranges in this range only. So 3000 RPM and 30 Newton meter. Let's say. Okay. Now you need around 807 RPM and 99 Newton meter in your wheel, but your motor is supplying this much. If you use a gear of 3:1, that means your RPM is reduced 3 times, but your torque is increasing by 3 times, right? That what does this is only this gear ratio means, right? So now from 3000 RPM in your wheel, finally whatever will be transferred, it will be of 1000 RPM. If you divide with this value with 3000 RPM, and your torque will increase to 30 into 3, which is 90 Newton meter almost. Okay. Further, if you calculate the proper value, you will get a better gear ratio. So based on these motor parameters and what is your actually wheel requirement is, you should select the proper gear ratio. Okay. Like this way, you should select the components for your powertrain, the main components for your powertrain. Now, if anyone has any questions here for selecting the powertrain component, please ask me. Please unmute and please ask. If anyone has any question. You can also ping over the chat as well. I can check there. If anyone has any doubts, any questions, please ping over the chat. Okay. I hope you don't have any doubts till now. So let me. So we have understood how to select different components. Now I will request everyone to please open your Matlab. Already I have opened it, and please click over this Simulink and create a blank Simulink window to start your modeling. I'm giving you some time and I will expect that everyone will follow parallelly along with me. Whatever I will do, please follow those things, because you will get more understanding and you will get more questions, more doubts from them. Okay. So I am creating a blank model here. So this is the blank model that I have created. Let me keep like this for some time, till the time you are opening your MATLAB. So please open MATLAB and confirm over the chat, and I will continue modeling from that point. Please open MATLAB and confirm over the chat. And meanwhile, if you have any questions, any doubts, whatever I have covered till now, please ask. As I can see, till now I got 2 responses, 3 responses. I'm waiting for other responses. Please comment over chat. I'm giving you 2 minutes of time to open the MATLAB, and please be ready with this. I'll start. Okay, 1 more minute. Please be ready with MATLAB. I will start them. I hope all of you can see my MATLAB window. So it's all. So without any delay, let me start the modeling then. So I will show you one modeling for a 4-wheeler vehicle. There I am selecting a 320-volt battery pack and motor, which will run on like a 94 kilowatt of motor. In real case, what we generally do, so as you have seen here, this powertrain component selection. So what we generally do, we repeat the same process, not for only a single drive cycle, for multiple different drive cycles based on the vehicle type. So suppose for the 4-wheeler, I am doing it FUDS, I am doing it WLTP, I am doing it MIDS, I am doing it IDC. Okay, multiple drive cycles, I am calculating the same parameters. Okay, and finally, once you do these things for different drive cycles, you should average the consumption rate, and after that you should consider a range, and you should multiply that average consumption rate value with the expected range to get the vehicle to get the battery pack image. Similarly, for the motor, you should calculate for individually all of these drive cycle, and finally you should consider the maximum value whatever drive cycle it has. Okay. So in real time, we not only consider in one drive cycle, we consider multiple drive cycles. Okay. And based on that, we select the parameter. So for this model, our vehicle mass is 1300 kg. I told you about our battery pack, and our motor is of 94 kilowatt. Okay. Now let's start the modeling. So before starting the modeling, first we need a reference block. So our model is going to be a closed loop system, which will see for some drive cycle reference, and based on that, our controller will be there, which will try to follow that driving pattern. And finally, it will compare the actual speed that we are getting from the vehicle with the reference speed, and it will try to minimize the error. Okay, like this way, our closed loop vehicle model will work. So for reference, we'll use a block called drive cycle source. Okay, this block, which comes under powertrain blocks. Now in Matlab, in particularly in Simulink, we will have a library browser here. It will consist with different types of libraries, which can be used for different purposes. Some are for physical signaling modeling, physical device modeling. Some are for mathematical modeling. Some are for control modeling. Different types, and for that different libraries. So most of the blocks that we are going to use for this modeling will be from Simulink, which basically powertrain block set also, and also some of the blocks we are going to use from Simscape library as well. Now, first I have taken this drive cycle source. Okay. Now, if I double click over this drive cycle source, I will have option to select the drive cycle, particularly which drive cycle I want to choose for our model. So let's say I am choosing WLTP class 3 type of drive cycle. Okay, this one. If you see the driving pattern, it's increasing over time. The top speed is increasing over time. Okay, this is WLTP class 3. And here you can specify the output velocity unit, which will be sended to the controller, and finally from the vehicle, which will be getting compared with. Okay. Let me change the output velocity to kilometer per hour. Okay, unit to kilometer per hour. You can keep this meter per second also. Then for the other components also, you should keep that in kilometer per hour. I'm making it to kilometer per hour. Okay. Once I've selected this kilometer per hour, I just need to click apply. So this is selected. Now, once I use this drive cycle as our reference, I should check for a driver block, which is basically the PI controller, which will control the whole operation. So for that, I am going to use a block called longitudinal driver block. Okay, this one, which also comes under this powertrain block. Okay. It has 3 input ports, 3 output ports. So this reference speed will go to the velocity reference. Okay. This is the feedback that we'll use after some time. And then we have this gradient value, the gradient angle. So I will not using this. I will not use this. I will keep it blank only, open only. I will not connect anything to it. You can use some gradient angle if you want to run your vehicle in some hilly area, or for some hill area. Okay, you can do. Then from this info port, you can get different infos for this longitudinal driver, which is not important for this modeling. But other two things, which basically gives the acceleration command and deceleration command based on this driving pattern, which is very important. Okay, we are going to use this. Okay, now if I double click over this block, you can see the control type is PI controller, and the reference velocity feedback you have to change for kilometer per hour. Okay. Okay, for kilometer per hour, I will select, because the input also I have selected for kilometer per hour. Now from here, finally, this command will go to my motor controller, which basically run our motor or control the motor. Okay. From this driver input, it will go to power controller. You can say motor controller, power controller, whatever. So for that, I will create a subsystem block. Okay. Subsystem is just a representation under which there can be multiple blocks inside. If I double click it, by default, it will have an input, it will have an output, and I can connect multiple blocks inside this power controller subsystem block. Now I am going to delete this output. I'm keeping this input for now. Okay, input one, and I'm copying this and duplicating this to create input port 2. Okay, input 1 and input 2. Input 1 will be for acceleration and input 2 will be for deacceleration. Let me connect it here. As I have created two input ports already, there two ports have been created. So the first one I know is for acceleration and second one is for deacceleration. I'm connecting. Let me increase the size also. Now, once I go inside, I need to use some blocks which will convert this signal that will be readable for other components which will act as a motor controller. Okay. So for that, I am going to use a block which comes under the Simscape library and called control voltage source. Okay. So I will search for control voltage source, which will comes under this foundation library. Okay. This is control current source. I will use control voltage source. This one, foundation library. This is a control voltage source. So for your is I am keeping this block name open. You can see the block name as well. Okay. Now you can see I'm not able to connect it because this library comes under the Simscape and this black color blocks are comes under the Simulink library. So we need to convert this signal type. It's not like same. The signal types for both these blocks are not same. So I need to convert this Simulink type to physical signal or Simscape type. So for that, I will use a converter called Simulink to PS converter. Okay, this Simulink PS converter, which comes under utilities. Okay. I'll connect here. Now I am able to connect it. So this is the acceleration one. Now same thing I should do for deceleration as well. So for that I'm simply copying this block and also this block as well. I'm copying it and I'm connecting. Okay. Now I need a block called control PWM voltage, which again comes under Simscape library. But as this signal will go from this one, so I don't need to further convert that signal type. Okay. So I will simply take controlled PWM voltage, this one. Okay. These blocks basically converts this analog signal in term of PWM signals that will be controlling the H bridge converter, and finally that H bridge will control the motor. Okay. Now this positive of this control voltage source, I will connect to the reference positive, and I will take here a ground, which will be called as electrical reference. Same from the foundation library, which comes under the Simscape blocks. Okay. Now this reference, this output reference, I'll simply connect with this ground. Okay. Now this reference negative also, I will connect with the ground here in the same line. Okay. Now here I am going to use a block which is called H bridge, which is basically the converter H bridge. Okay. This is the block H bridge. So I'm keeping this block name also on. This block name also on. Also, let me keep this block name on and this one. Sir, we can't see the options for drive cycle and longitudinal block. Uh, actually, you need a library called powertrain block set. Okay, so you can go here and you can add that library. So you can come up to this Matlab window and you can click over this add-on option. Okay, get add-ons. You can click here. So whenever you click, it will open up open up a screen like this. Here you can search for powertrain block set. Powertrain block set. See, click this, and here already I have installed, so it's showing installed. So in your case, it will show here some installation option. Okay, you just need to click that. It will automatically add it to your Matlab. Okay. And for the other guy who is not getting WLTP, you can use any other drive cycle also. It's fine. Okay. Is any other doubts? Please tell me. If there are any other questions or doubts, if you are facing the difficulties, please tell me.
सर आपका मैटलैब कौन सा वर्जन है?
This is 2023B, I think. Yeah, 2023B. This is the latest one. It doesn't depend on the version. The options will be same. You
सर
can
वो
click that.
ड्राइविंग रेंज वाला क्योंकि हम लोग को शो नहीं कर रहा है. इट्स नॉट
Actually,
शोइंग इन आवर
actually,
सिस्टम.
the thing is you have not added that library. So that's why I told you. You click on the add-on option. You can see my screen, right? You can click in this add-on option. You can click this get add-ons. Okay. Here you can search for powertrain block set. Powertrain block set. This block. Okay. Click this one. Here you will get an option to install. Here in this here you will get the option to install. Just click that install button. It will install and it will add there. Or else I will tell you another way to do this. Let me continue. Whatever blocks you have, just continue that. If you're still facing the same difficulties, I will tell you some alternative option also. Okay. For now, just follow it, and whatever the blocks you have, just connect those things for now. I'll explain the overall model, and I will give you some alternate option also. Okay. Now it's time to connect the H bridge, right? Now to connect this H bridge, this PWM signal, which is coming from this controlled PWM voltage, I need to connect it here. Okay. Let me just put it here. Let me just increase the size also. Okay. Then this reference, I will connect it in this ground also. This reverse also, I will connect it to the ground. Okay. This brake, I will connect with the deceleration. Okay. This negative of this acceleration control voltage source, I will also ground it. I will connect with the electrical reference. Okay. And this one also, I will connect with this electrical reference. And finally, remember, whenever you are dealing with any Simscape blocks, you must need to add a block called solver configuration in your Simscape model. Otherwise, it will not run. It will get some error. Okay. So this is the solver configuration. Just anywhere you can connect here, here, anywhere. For better like visualization, I'm connected here. Okay. Now, once I have connected these things, now the next thing is to connect the current source. Okay. So which you will calculate the required current, and based on that current, it will draw from the motor. It will draw from the battery. Okay. So for that, what I will use, I will use a block called current sensor. Okay. Same from the foundational library. Okay. This is the current source, current sensor block. So positive terminal, I will connect it here. So to complete the thing, I will use here a block called connection. I can simply type CONN, it will show me connection port. Okay. This thing I will connect it here. Let me rotate this. Okay. Connection. Then from here, I need to use a block called controlled current source block, but from different library, from Simulink library. Okay, so I will search for controlled current source from this one, this electrical under this specialized power system. This one I will take this one. Now, as you can see, the color is different, black and this one is blue. So again, I need to convert the signal type. So in this case, I was converting from black side, from Simulink side to Simscape side. But in this case, I need to convert from Simscape side to Simulink side. So I need just the opposite converter, PS to Simulink converter. PS to Simulink converter. Okay. Let me put it here. Okay. I've connected this. Let me connect this block here. It's connected. Now this positive terminal and negative terminal I need to connect with the battery. Okay. So let me take same block connection port. Okay. So one thing I will connect here. Let me rotate this. Okay. Another block I'm simply I'm clicking right click and dragging it. Okay. To copy it. Okay. I'm putting it here. So connection port 2, I need to connect it here. It's connected. Let me name this. So this one I will name as positive, and this one I will name as negative, to understand that which is the battery negative terminal and battery positive terminal. Okay. Now for the motor also, let me write here. So I'm writing M positive and M negative. M positive, okay. This will be motor positive terminal. And another terminal I need to use here, which I will copy from that also, and I will name it as motor negative. Okay. Now this thing I need to connect with this negative terminal, and also I need to ground it. So to create a signal from here, you just right click here and drag. Okay. I will ground it here. So this is my motor positive, this is my motor negative, this is my battery positive, this is the battery negative. Okay. So till now, I hope everyone is done with this, or should I wait for some minutes? Please tell me.
Wait.
Okay. Now, once you are done with this, I will set some parameters here. Just let me know once you are already done with this. Confirm me over chat once you are done with this.
So,
How to create subsystem. Okay, so to create subsystem, so similarly like you are fetching this block, right? You just need to double click over this blank screen and you just need to type subsystem. Okay. Or there is another way. Once you have created or connected multiple blocks together, you can just select overall section and then you can click this dot option, and you can create subsystem. This option also you can choose.
sir, what is this block called which is connected with electrical reference?
This is called solver configuration.
Okay, okay, sir. Thank you.
Viraj, if you don't have option for this control PWM voltage block, what you can do, you can add same way this library. The control PWM voltage, this electrical you can, I think you will have this thing. If you have already added SimScape library, you will have this.
Sir, in a subsystem, how to delete output port?
You can just simply select that. Suppose I want to delete this thing. Okay. What I will do, I will select this and then I can click delete button. Or else you can just right click on it and you can also like cut it or whatever you can. Once you are done, please confirm over chat. Okay. I'm giving you 2 more minutes of time. Please complete this, then I will go forward. Thanks, Omkar, for confirmation. I'm waiting for others. Please confirm. I will go forward then. 1 more minute, guys. Please confirm.
Sir, I cannot find the controlled PWM voltage.
You are not able to find it. So what I will suggest you, same way, you go to the MATLAB window, go here, click this add-on option, get add-ons. Here you search for Simscape, Simscape electrical. If you add Simscape library, then you will get all the things. Simscape, okay, this one. The Simscape electrical you need to add this one. This one. Same here, you will get the install option, you can add it. There is no alternate for this control PWM voltage block. I can still show you alternate for that longitudinal driver. You can use it you can use some PID controller, PI controller there. But for this, there is no option alternate.
Okay, sir.
Okay. Okay. Let me parameterize these blocks. Okay. So first for this control PWM voltage block, So first we will set the PWM frequency. So the sampling rate for generating this PWM signals will be of 1800 Hertz. Okay, so I'm specifying 1800. Here, the simulation mode, I will make it average to fast faster this simulation process. You can keep this PWM also, it will take longer time. So make it average. Okay. Then this PWM voltage input scaling at 100% duty cycle, make it 1 volt. Okay. And this output voltage amplitude for this control PWM voltage also make it 1 volt. Okay. Just these 3 parameters you need to change, 4 parameters. 1800, make the simulation mode to average. Then keep this input voltage for 100% duty cycle 1 volt and output voltage amplitude to 1 volt. Okay. Just make these things. Then save it and close it. Then parameterized for H bridge. So H bridge also quite same. Here we should give the output voltage amplitude based on the motor and all. So first for this power supply, it will be internal only. Simulation mode here also, as we have changed earlier to average, here also we'll change it to average. This regenerative braking flag will make it always enable, suitable for linearization. It will be faster enough to make the simulation process faster. No need to change anything here. Here enable threshold voltage, you can make the enable threshold voltage to 0.9. Here PWM signal amplitude, you make it to 1 volt. This reverse threshold voltage also make it to 0.9 volt. And also this braking threshold voltage same as 0.9 volt. Now for output voltage amplitude. So output voltage amplitude will be same as the voltage of your motor, the motor rating. So we are going to select a motor which will run on 320 volt. So here also I am making it 320 volt. Okay, that's it. No other change. Okay, you just click save, then apply, and then click OK. Okay, these are the parameters that we need to change. So let's go back. So this was the subsystem that we have already developed. Now for our designing goal, let me change the sides for this port. So motor, I am connecting this side, right side. So I am making motor positive and negative terminal this side, and battery positive and negative I will keep in the top. Okay, like this way. And now still you can see whatever subsystems you have built inside, that you can see here. To stop it, you can go to this format option. You can turn off this content preview. Okay, it will make it blank. Now if you want a better visualization, you can go for mask. Okay, you can go to add icon image. Here you can browse any image you have that you want to show here. Suppose I want to show this controller image here. So I'm selecting this, I'm clicking open, then I'm clicking OK. Okay. Now you can see the subsystem is looking like that. Okay. Now time to connect motors and other components. So first, to connect the motor, similar way, we will first create a subsystem by double clicking it. Subsystem will search for, and here we will go inside, and we don't need this input and output actually. We'll delete this. Okay. So first we will go for a motor. We will search for a synchronous motor, synchronous permanent magnet motor, PMSM motor. So which is a DC motor. Okay. So I will search for this DC motor. Okay. This is the motor. So I will just rotate it. Okay. So you can read about this motor in this description section, or even all the other blocks also. You can read the description section, how this motor works, what are those ports means, those things you can read here. Okay. Now, this positive and negative terminals are there. Okay. So I will look for connection ports that I need to connect with this controller positive and negative, right? So for that purpose, I am taking this connection port And similarly, I'm copying here the second port and connecting here. Okay. So this side is positive, this side is negative. So 2 is my positive and 1 is negative. Okay. 2 is positive. Let me change the side also to connect it easily. Okay. 2 is my positive. 1 is, oh, sorry. Okay. Let me change the name here itself so that we can change it. So make it, let's make it, okay, already it's changed. Okay. 1 is positive now and 2 is negative. I have changed there, so already it has changed inside. So 1 is positive, right? So positive to positive and negative to negative. Okay. Connected. Let me increase the size. Okay. Now let me go inside. Let me connect other things now. So if you see this motor, if you read the description, so torque will be transferred from C side to R side. So direction is this side. Okay, as you can see in this arrow. Now to make it static position, to make it idle position, I need to connect a block which is called mechanical rotational reference. So I will search for it. Mechanical rotational reference. I will rotate it and I will connect it in the C. This is the reference one. Torque is transferred to the R side from C to R. Okay. Now here I will use a gearbox. Not this one. Gearbox. Just a minute. Gearbox from this foundation library. Okay. From here. Okay. This is the gearbox. So I need to connect S to the R and O will be my output. Okay. And that will I will connect with the connection port, another port, which will connect finally to the vehicle. Okay. Let me rotate this. Now to measure the input speed and output speed, what we can do, we can use some sensor here, which can we call as ideal rotational motion sensor. Okay. So we'll search for ideal rotational motion sensor, same under foundation method. Okay. This is the R is the input which will sense the speed. So I'll connect it here. C also same as this mechanical rotational reference. I need to reference it. Okay, so I have connected it here. Let me rotate this. Okay. Now W is actually the output signal through which you can sense the speed actually. Okay. So we need to convert this. I can use here input, not input actually, output, out one. Okay. But see, I'm not able to connect because of the mismatch in the library. So I can use here a converter which can be PS to Simulink, okay, which is converting this physical signal in terms of Simulink signal. Okay, I can connect it here. Okay, let me connect it freshly. Okay, this is my input speed. Let me name it also input speed. Input speed. And this side we should here I can terminate this port. As I'm not using, I can use some PS terminator to terminate this port. Okay. Similarly, here also I need another thing. So I'm copying it by Control C, selecting and Control C. Here I'm clicking Control V to paste it. Okay. This will be my output speed. Okay. So R I will connect it here, and this I will name as output speed. Output speed. Okay. Now, once I connect this, now to give a inertia effect in our transmission, I should use a block called inertia. Okay, I will search for inertia. Same under foundation library, I will connect it here, okay, like this way, and this will be my gearbox output. I'm writing like this way, gearbox output. Okay. Let me show you the names for individual blocks. This is the gearbox. This is the rotational motion sensor. This is PSW. Okay, and this is called inertia. Okay, now we should parameterize it. We'll parameterize it. So please connect all these blocks and let me know. I will parameterize it. Once you connect this, please tell me. Please confirm me over chat. If you have any doubts here, please tell me. Also, once you are done, please let me know. Let me parameterize it till the time you are doing. So first we will parameterize this DC motor, then we'll parameterize the other component. So inside this DC motor, if you double click, you'll find this settings option. Right? So go there. First, let's confirm that it's selected to permanent magnet. And this model parameterization is selected by rated load and speed. Okay. Now here, for this no load speed, set to 6000 rpm. Okay, and at a rated load, make it a lesser value, let's say 5000 rpm. Here, the rated load, the mechanical power, as I told, it will be of 94 kilowatt of motor. So I make it to 94, and here I will change the unit to kilowatt. Okay. And finally, here I need to provide the supply voltage, which will be of 320 volt. So I have selected to 320 volt. Other things, nothing need to change anything. Okay, but keep it as it is. Now just click apply, save, and close it. Now time to parameterize these things. So already velocity and position is checked. So we need actually these two things only. So we have already checked this. So no need to change anything here. We have to change something here inside this gearbox. Now we need to specify the gear ratio. So based on our calculation for this vehicle, our gear ratio should be of 4.5. 4.5 is to 1. So I have changed the gear ratio value to 4.5. Okay. No other things need to change here. Just click enter, apply, save, and close it. In this inertia also, you no need to change anything. Just need whatever the default values are, just keep as it is. Once you are done with this, please tell me. I will move forward. There are other things also. We have to model it and we have to run it. We have to check the performance and all. Those things are left. Please let me know once you are done with this.
So here we have to make changes in two things, right? Ideal motor and gearbox. Here,
yes, only two things. This DC motor and gearbox. These two things.
And what changes we made in DC motor? Can you please show?
I'm not able to hear you properly. You are asking about the parameters, right? What parameters do you set it?
Okay.
So these are the parameters. No load speed. So first is make sure that field type is permanent magnet. So it's a PMSM type of motor. Model parameter is change it to by rated load and speed, because other parameters is quite difficult to get from the manufacturers. Okay. So make it rated load and speed. Then set the no load speed for 6000 rpm, whatever the specification will say for the motor. For this motor, the specification says that it is of 6000 rpm, no load speed, and rated speed is of 5000 rpm. The rated load mechanical power is of 94 kilowatt, and the voltage supply is of 320 volt. That you have also seen in the earlier edge bridge output voltage amplitude. Same voltage we have set up there also. So 320 volt. These are the things you need to change here. Okay. And for gearbox, just make the gear ratio to 4.5. That's it. This is basically the peak power value that you have seen in the calculation also. The same peak power value we have to mention here, not the continuous one, the peak power value. Okay. At a rated load, how much peak power it can deliver, that value, that peak power. Once you are done with this, please tell me. Okay.
Sir, what is the block called input speed, output speed?
This
What is
block is called ideal rotational motion
no
system.
no input speed, input speed.
Same block, same block.
One which is like capsule input speed connected with W.
Okay, okay. This block. This is same block as PS to Simulink converter.
फर्दर
This
आगे
one.
का उसका हाँ हाँ, वो वाला
This is called output. Out one.
ओके ओके
Mhm. Output. Please let me know once you are done. Please comment over the chat. Okay, thanks, Dheeraj. Others, I'll wait for 1 more minute in this subsystem, then I will move. I'm moving from this. Okay, thanks, Omkar. I'm moving from this. So let me go back. Similar way, here also this input speed and output speed, I will change this position to top, and gearbox I will make it in the right side. Okay. And I can connect some masking option here also. I can choose the photo, whatever photo you have, you can also choose it. Let's make this. Okay. Now time to connect other blocks like the vehicle and other things. Okay. Now before that, let's connect the battery one, and then we will go for the vehicle body and all. Okay. So for battery, again, similarly, we will create a subsystem. Okay. In the subsystem, I will delete these things and I will search for a battery. In ideal case, there will be so many cells that will be connected there, but to make our uh, simulation faster, because it will, if you connect multiple cells, it will take too long to simulate. Okay, maybe 1% will take 1 hour. So to make it faster, I'm using a single battery, but I will parameterize it based on the battery pack ratings. Okay. Now battery, you should select this one, electrical under the specialized power system source. This battery you should select. Okay. Because here by default you will get the parameters like SOC, voltage, current to compare it. Okay. So let me rotate it. Okay. So this is the positive and this is the negative. So what I will do, I will take connection blocks, connection ports basically. One for positive, and similarly I will copy it for negative one. Okay. Let me rotate this also. Let me rotate this by Control R. I can rotate it. Okay. So I have already rotated. So remember, one port is connected to the positive, two is connected to the negative of the battery. Okay. Now this import, from import, whatever signals are coming, we can read those using a block called bus selector. Okay. So I will search for bus selector. It also comes under Simulink. This is the bus selector block looks like. It has one input and by default you can see two output ports. But whatever outputs we need, we can select here. Just double click over this bus selector block. You can see by default selected elements is showing signal 1 and signal 2, these two, but it's not anything related to battery parameters. So I will simply delete it. Now what parameters we are getting from this input of the battery? SOC we are getting, current we are getting, and voltage we are getting. So I will log all this. So I will click here, I will select this, all these three. I will click this select element option. Okay. Okay, once I click this, all these things will be ticked and it will comes under this selected element section. Now I need to click apply and OK. Now you can see there are three ports, right? So individually these three ports, you can check the data. Now to check the data, what I will do, I will connect it with some output ports, and in the outside of the subsystem, I will observe those values. Okay. So I'm taking outputs. This is one output. So by default, it's showing this is the SOC one. Okay. This is the SOC one. Then I will take for another out. Okay. This is what? This is current. Okay. Let me rotate this. Okay. This also. And finally, the another one will be obviously voltage, because these are the three signals we have selected there. So out one, this is voltage. Okay, you can see voltage. Now let's parameterize the battery. What parameters we need to give here? Now you remember we have already selected a motor which is capable on running in 320 volt. So same voltage parameters we have to give here. So nominal voltage is of 320 volt. Rated capacity, let's make it 150 or 158. The initial state of charge. So what is the initial charge percentage? Okay, let's make it 90%. Okay, apply and okay. And battery type, you can see it's by default selected to lithium ion. So whatever batteries you are selecting to make this overall battery, it's a lithium ion type. Now click OK. Now I'll go back. Now remember one thing. Okay, let me do one thing. Let me select the name because otherwise it should be little difficult. So this one is bat negative, right? And this one is bat positive. Positive. Okay. And let's go. Let me rotate this like this one. Okay. Now remember one thing. If you see here, the one was positive and two was negative. Now while connecting to the battery, this positive terminal will go to the negative terminal of the battery, and negative terminal of this will go to the positive terminal of the battery. Okay, remember this. Just a cross connection. Here it was like same connection. Positive was connected to the motor positive and negative was to negative of the motor. But here it will be cross. Positive to negative of the battery and negative to the positive of the battery. So we will make it cross. This is the connection one. Connection one means positive. I will connect it here. The connection two, I will connect to the negative. Okay. Let me confirm once again. This is the one that was positive and two was negative, right? So I have connected in a cross manner. You can see. Now here I can put some display block to see the numerical values, okay, of different parameters. Like this is what? This is first one was SOC, second one was current, and third one was voltage. Okay. Let me also write if you want. I can write here. So this one is SOC. Let me copy this block. This one will be, let me say, voltage, and another one I need, which will be, let's say, current. How much current is going from the battery to motor? Okay. This is current. This is the current and this is the voltage. All the three signals are connected. Now this system is almost done, but still we have not connected our vehicle yet. Okay. Now we have to connect our vehicle. So let me connect vehicle. So to connect the vehicle also, we will use a block same as subsystem, and inside that subsystem we'll put all the required blocks. Okay. Now here we will delete this. We need a connection port basically. Connection port. Okay. Now we need a main thing, which is basically the digital or virtual representation of a vehicle, which is basically vehicle body. Okay, we will use this vehicle body. Now inside vehicle body, we have to parameterize the vehicle. What parameters? First is the vehicle mass. Let's make it 1300 kg. Okay. Number of wheels per axle. This is two only. It's a four-wheeler, so in each axle there will be two wheels. Okay. Then we have horizontal distance from CG for the front axle and also to the rear axle. So I will keep both the values same. Okay. CG height from ground, same value I will keep it. Other things also I will keep as it is. Now for other points, drag, pitch, air density and other things. So air density value I will change a bit. I will make it 1.225 kg per meter. Okay. Then in pitch, I will pitch dynamics, I will make it on. Okay. And I will keep the default values here. Okay. And the other things like initial targets, nominal velocity, nominal value, I will not select anything here. Okay, I will keep as it is. Frontal area already I have kept 3 meters square. So as it is. I'll keep the rest of the things as it is. It's auto applied, I will close it. Now, once I parameterize the vehicle, I need to connect wheels here. You can read about the vehicles in the description section, like what does this ports means, this of these ports. I'm telling you, this is for rear axle connection, this is for front axle connection. If your vehicle is going in some angle, downhill or uphill, so that angle you should specify here. This is the wind speed. If your wind speed is opposite side, in which direction your vehicle is moving on the same side, you should specify that. This is the vehicle speed actually that you are getting. This is the hub connection. Okay. Now let me connect the hubs. Now to connect the hub, first we need wheels, right? For wheels, I will use block called tire, but for the magic formula, this one. Okay, magic formula tire, this one. Now let me rotate this. So N is basically which will connect to the axle of the vehicle. Okay, so this thing is going here. Okay, similarly, I need another wheel. This N also will get connected to this same thing. For the other two axle, I will copy this. I will connect it here. This thing I will connect to the front wheels. Okay. Now, once this thing is connected, let me rotate this too. Let me rotate this. Okay, like this way. Let me put this thing this side. Okay, it looks better. It looks better. Now, this, if you want to read about the description of the wheels, you can read. So S is to measure the slip value, how much slipping is happening. A is to connect the axle. So this two will connect to here, and this two will connect to each other. And this is the final output that is coming from here and from the motor and through the gear, which will connect to the axles. Okay. As it's a four-wheeler, so four-wheel drive, we are connecting to all these four wheels, okay, in the same axle. Okay. Now, once we connect this, now time to connect hub. Okay. Hub, how we will connect? All the wheels will connect to the same hub of the vehicle. So we'll take this. Again, from here, we'll connect this. Again, we'll take a signal from here. We'll connect this and this thing here. Okay. All the hubs are connected. Now what we need to do, this S port we don't need actually. We can terminate this using terminator block. PS terminator. Let me rotate this. Let me copy here. Let me copy here. Let me also copy here. Okay. Let me rotate this to this one. So S connected. Here also S connected. Here also S is connected. And here also AC is connected. Okay. Now what is left? Now left is the vehicle speed, wind velocity, and the angle. Okay. Now what we will do, we will specify an angle that is of 0. Okay. So to specify that, I will use a constant block. Basically, as it's a colorful one, so it's a PS constant. Okay, it's a physical signal. So we'll use a block called PS constant. One for wind and another will be for angle. Here we should specify the value of angle in a radian. Okay, so what we will do, angle is 0. Okay, 0 radian. So I can specify here also radian. Okay, this radian also I can specify. I will just make it unitless. it will not make any change because the angle is 0. Okay. Here also wind speed I am keeping as it is. I will make it 0. Then this is the velocity. Let me do one thing. Let me lower this down. Okay. Now this is the velocity block, right? So from this we will get the actual velocity of the vehicle. Now we will use a block which is uh, basically output. Okay. Now same issue will face here. It will not get connected because it's coming from different library. So we need to use a converter. So PS signal we are converting into a Simulink signal. So PS to Simulink converter. We use it. Control R to rotate it. Here I will connect it. Okay, it's connected. Now let me specify here the speed is in kilometer per hour. Okay. Now what are the things left? We can also measure the other things like how much distance it has covered, how much longitudinal force it has went through. So to do that, we need several sensors. So first, to measure the distance and velocity, we will use a sensor called ideal translational motion sensor. Display. Okay. This R we will connect to the hub connection. Let me put it a little up. So V is the basically the velocity. P is the position or the distance. Okay. So what we will do, we will connect output ports here. One for this one. The same issue. You can simply copy this thing and you can use it here. Connected here. Same thing. Okay, there is some connection issue. So let me connect like this way. So this is speed, and let me copy another thing, which is basically our distance. Let me change the signal name as distance. Okay. Let me check what is the distance unit is set here. Based on that, we have to write it. So if I double click here, you can see the measurement reference is the difference and initial position is 0 meter. Okay. Just keep it. Now C is the reference one. So again, we need to like put one mechanical translation reference here. So we'll search for mechanical translational reference. This one will connect it here. Okay, let's rotate it. Okay. Now, once this is connected, if we want to measure the longitudinal force also, we need to use another sensor called ideal force sensor. So we'll search for that. Ideal force sensor. Okay, this one. Same to both of these are same. Oh no, this is source, this one is sensor. So we will use sensor, which we are going to measure it. So same thing will connect it here. F is basically the output signal which port will provide. Let me copy this. Okay, let me copy this. Let me connect it here, and this is nothing but the longitudinal force, right? That is applying on the wheels. Longitudinal force. Obviously, unit will be Newton. Okay. And C, we will connect it back to the other wheel sub. Okay. I can connect it here. Okay. All the things are connected now. So vehicle parameters we have set. Still we have not set the wheel parameter. So let me check once what are the wheel parameters are there. So in the settings option, all the parameters are almost same as it is. So no need to change anything here. Okay, we can keep as it is. Okay. Here one thing you can change. You can make the velocity threshold, like the difference threshold that it will look for. So the accuracy you can increase by adding it with another 0.1. The accuracy basically increased. Okay, accuracy of the sensor. Then the minimum valid wheel slip you can reduce it further. So let me make it e to the power minus 5 means 10 to the power minus 5. Okay. Actually e to the power 5 minus e to the power 5. Here also maximum thing also we will make it to e to the power 5. Okay. Inertia and other things we will keep as it is. We will not change anything here. We just close it. Here also in this ideal force sensor also we will not change anything. All the setup is almost done. So I am giving you some time. So please do the same thing and let me know once you are done. For your reference, let me turn on the block names. So that is vehicle speed, that is PS constant. Okay. This is basically ideal rotational motion translation motion sensor. This is mechanical translation reference, and this one is ideal force sensor. Okay. And this is PS terminator. And this one is PS Simulink converter. Please do this and let me know. Or if you have any doubts here, then also please tell me.
Sir, what is add-ons required for tire?
So for this, you need a block called drive line library.
Uh, tire,
Yeah,
drive
same
link.
drive line.
Okay, okay.
Wait, let me show you. Drive line. So if you add this drive line library, so tires and vehicles, all these things will come. Drive
Okay,
line.
okay, sir.
So for the first wheel, I have changed these parameters. For the other wheels, I have not changed. So that's why I'm changing these parameters. Please let me know once you are done with this.
मजा आ रहा होगा भैया आपको हाँ आप तो आदत
Please let me know once you are done with this. I will be waiting for 2 more minutes in this subsystem. Then I will go forward. If you guys are stuck somewhere or if you are facing doubts, please tell me. Already 3 minutes has passed. So should I move now or should I wait for a few more minutes? Someone please tell me. Okay. As you are not saying anything, I'm thinking that you are already done with this. So I'm moving then. Okay. So now as we have connected all these things, now time to organize these things, right? So gearbox output will connect directly to here, right? And this one is basically our vehicle speed, right? That we have to give feedback here. Right? So what we will do is simply put it, sorry, okay, okay, let me check once. Yeah. Okay. One more thing I forget to tell you. So here, if you double click over this black one, you will find this vector format output signal unit. Here you can specify the unit as kilometer per hour. Okay. Kilometer per hour. Or you can, as this is not showing here, you can simply type here also. Kilometer per hour. Okay, you can type also. Okay, this will be kilometer per hour. Or you can also keep inherit as well. Mostly K will be in small. Okay, kilometer per hour. Yeah, kilometer per hour. This way you need to write. So all everything in small. Okay. Now, once you set these things, let's go back and you have other things like this velocity and all. So velocity we have to give as a feedback here. Okay, we are connecting it here. Here we are taking one scope to see the graph of input speed and output speed. So I will connect it here one and another one I will connect from here. Okay, this side I will. Let me specify the signal name. This is the output speed. And this one is our input speed. Okay. Now there are other three things here. So let me see. So one is velocity. Here also we can change the unit. It is not in kilometer per hour. Let me make this unit in meter per second. Okay. This unit, which is coming from this ideal translational motion sensor. 2 is our speed, 3 is our distance, and 4 is our longitudinal force. So let me take one scope also here, through which we are going to observe the graph. 2, 3, and 4. Okay. So 2 is speed. Let me write also. Speed. 3 is the distance. Okay. And fourth one or the last one is the longitudinal force. I think like force only. Now almost the things is done. Only things that are left is to put some blocks which we must need to put whenever we will use some blocks from specialized power system library. So if you remember, so the block of battery that we have used that was comes under the specialized power system library. So we need to use a block called power GY and need to keep anywhere in the model. Okay, that we have done. Now, as you can see, the WLTP class 3 rise cycle is for 1800 seconds. So I will set my stop time also to 1800 seconds. Okay. And now I'm good to run this model. Let's run it. Let's see. Okay, so our model is running. You can see. Now I forget to connect another scope to see how good our controller is working in terms of following the reference code. Someone is unmuted. Please mute yourself. Okay. So here, let me take one scope block. So we know what is our reference speed. That is this one, right? Let me put it here only. Okay, keep it here only. So this is our reference speed, right? We are trying to follow with our velocity, actual velocity from the vehicle that we are getting. So let me take these two things so that we can compare. Okay, this is our reference, and let me put in the this side, and this one is our actual speed. Okay. Now again, let me run once again. Okay. The current is changing, SOC is also changing, but as there are deceleration, so at that time it's also parallelly regenerating. That's why SOC is changing, increasing, decreasing, and current is also sometimes becoming positive, sometimes negative. So during discharge, it should be negative. When it is positive, that means that time it's recharging, it's regenerating. Now let me check your scope. As you can see, let me turn on the legend so that you can view what is our actual speed and what is the reference speed. So actual speed is in blue line, blue color, and reference speed is in yellow color. You can see, so it's basically overlap. That's why you are not able to see properly, but some points it's still not following properly, like this regions, some points in this regions, it's not following properly. So you can see those yellow lines as well. So moreover, if you overall consider this thing, it's following in a very good way, right? The reference speed and actual speed is following very good way. So this is the thing that we should check. Now you can further modify this model. Suppose you want to run your vehicle like in normal EV, what are the things? So you should have several modes, right? Some are city mode, some are sports mode, some are eco modes, right? So you can select those modes as well here. How you can select? So for that, you have to little modify these things. So what we will do, we'll use here a block called saturation block, which can control the positive and negative values. Okay, this one in between these two. And here we will use a block called rotary switch. Okay, rotary switch, which comes under Simulink dashboard and customizable blocks. Okay, this block. Here, if we click this point, it will suggest us to select some points. So I will select this saturation, and here I select this upper limit. Okay. Once this is done, you can click this cross or you can press escape button as well. Okay. It's connected. Now what we will do, we will double click here. We'll go inside this. So you will see several steps, right? Now here we will specify the value. Suppose our mode is called eco mode. Okay. In eco mode, let's say our vehicle should not exceed a top speed of 50 km per hour. So I'm specifying here 50. Then we have city mode, where our top speed should not exceed beyond, let's say 70 kilometer per hour, or let's increase it to 80 kilometer per hour. Okay. Then we have our sports mode, where our speed should not exceed beyond 140. Top speed limit is 140. So these are the three modes, and other two modes we actually don't need. So we can simply delete it. We can click this delete button, or we can click this minus button as well. Let's select this, select the whole thing. Let's click this minus button. Okay. So these are the three modes that we have selected. Now what we will do, we'll click apply and okay. Now you can see, okay, only two modes it's fine. Okay, just a minute. Okay, by default it got changed. So let me make it eco, city, and sports. Okay, let me click apply and okay. So you can see eco, city, and sport. Let's say we are keeping to eco mode. So based on eco mode, here our reference value will also change. Okay, lower limit, let's make it 0. Okay, lower speed, and upper speed limit, it will be by default set based on the values that we will keep it. Okay. Now let me run this. We have kept it in eco, right? So if you see here in the saturation, upper limit is 0 only. Okay, let me click once here. Actually, here it should do some little change here actually. So user selected, lower limit is also selected. So somehow it's not reading this saturation upper limit. Okay. So here I should change a little thing in this block basically. Let me check once again. Sir, I think you have not assigned the values in the rotation. I have assigned the values, Omkar. I have assigned the values. Okay. It is changed again. 50, I made it to 80, and this one is 140. Okay. Thanks, Omkar. I have changed it, but somehow it changed again. Let me confirm once again. No, now it's okay. Okay. Now I'm keeping it to eco, right? Let me run it. So our top speed should not go beyond 50 kilometers per hour of speed. Okay. That's our expectation. Let's see. See. Okay, let me make another little change to show you this thing more properly. Let me delete this. Let me connect from here. So actual what is input coming, so that you can see that. Okay. Now let me run it again. Okay. Now see this. See, though our reference speed is going more than 50, this is the 50 point. Right? But our actual speed of the vehicle is not increasing beyond 50. So whenever it's 50, it's still like more than going more than 50, it's continuously maintaining 50 km/h of speed. Okay, as you can see. Now let me change it to, let's say, sports mode. Okay, where top speed is 140. Okay, I've changed it. Now let me run it. Okay. Now, if you see, you will see like whatever the speed is going for, it's going to that value only. Because like top speed here is not crossing 140, it's like 130 or so. So it's going to the max value. Okay. There are other dashboards also that you can use for SOC monitoring, current monitoring, voltage monitoring, or even for distance monitoring. Okay. Now I will show you another model that I have already prepared. There I have used some other visualization dashboards as well. The parameters of each of the things are same only. Only difference is here. Like I have used some SOC indicator here to see this SOC value. I've used RPM, motor RPM to check the input speed, input RPM value of the motor. The vehicle speed that I am getting actually from the vehicle, that vehicle speed I am logging here. And this is the distance travel. Similar way, if I, it's already set to eco. Let me set it to sports mode. Okay. Now let me run it once again. So how like this speed is increasing based on these different steps. The last step it will go till 130. This is the RPM values and this is the vehicle speed in kilometer per hour. And this is the distance that is getting calculated here. You can log the distance value from here. Okay. The signal that you have created, you can connect this thing there. It's just a dashboard. Okay. I'm telling you each of the name for individual each of these interactive things. Okay. This is called display. Okay. This display is not same as this display. This is different library. If you search here and display, see, there are so many display. You select this one, the Simulink dashboard or this Simulink dashboard customizable block. This any of these two. Okay, for this one. Now this is same as you have seen. This is circular gauge. Okay, this also like same thing. You need to connect similar way. Here, if you search, the circular gauge will be also under this Simulink. Okay, circular gauge. See, Simulink dashboard and customizable block. This is another block which